Okay, let us start. So I will talk on twisted representations of the algebra div Q and twisted W-algebras, but let me start from like a bit like something at first glance non-related. So there's a well-known formula for Virasoro algebra, not q-Virasoro, just ordinary Virasoro, with central charge equals to 1. And so here we see a sum of R and S are half integers. So it's like plus minus 1/2, plus minus 3/2, etc. And so it's a well-known formula. One can find it in a paper of Zamolodchikov. Yes, and also it's essential that it's C equals 1. We do not know what is like an analog for general central charge. Probably it does not exist. But the question is, what is correct Q analog of this formula? So there's a q-Virasoro algebra. I will define more general W algebra, but the question is what is, so I want Q deformation of this formula to satisfy relations of q-Virasoro. And it was the question which Misha asked me, I guess, 4 years ago. And we somehow have a guess that the answer is 2 exponents, as always in this business of q-Virasoro, but we did not succeed to guess
So you want a representation of q-Virasoro in the space
of Fock space.
Fock space of periodic boson.
Yeah, exactly. Fock space of this Heisenberg.
Just in this Fock space?
Yes, Fock space for this. Yes, and it was more or less clear that the answer should be like 2 exponents, and we did not guess the answer. We did a long way. We created a machinery which made the formula for us. We did not get the formula, but now I think that the formula, here's the answer. It's the only reasonable formula one can guess. So let me say something about the formula. So here is R, and R is again these half integers. The summation is over half integers. So we have something half integers, some half integers power of z. Then we take the exponent, and we have both half integer and integer powers. But t of z has only integer powers. So we add this exponent to this exponent. And it is an easy exercise to see that all half integers powers of z cancels.
What should be surprising?
For example, I think that maybe
there exist integer terms in the expansion.
Yes, they are like both integer and half integer terms.
So you said so that integer terms they disappear, or what?
No, half integer terms disappear. Like I obtained a representation of ordinary Virasoro. So there are only integer terms, integer powers of z, and so they have to cancel.
And so they just cancel.
Yes, and this is quite evident.
Наивно вот написать для экспонента и подбирать коэффициент.
Yeah. It's exactly what we did. We tried to find the coefficients, but we somehow I thought I did not guess that there has to be half integers powers because I lack of physical intuition. Okay, maybe this formula is obvious for you.
Not obvious, but just if you take current in this upper part, it will be also expanded over half integer form. But the square will have
Yes.
So that's, in that sense, it's similar to classical cubes, right?
Yes, it's similar, but
we have function x squared, which is even, and we have a function cosine, which is also even. This is the same phenomenon.
Yeah, that's why.
Yes.
Like cosine.
That's why I'm asking where I should be surprised.
yes,
Maybe no.
maybe you shouldn't be surprised. Maybe your physical intuition would help you to work. Yes. Okay. But I will explain how one can obtain such a formula, not guessing, but using some general machinery, and also to obtain a lot of different to generalize this formula. This machinery gives you a lot of formulas, so you will see. Okay, so let me start from Lie algebra div q. So it's a preparation for the definition. So first of all, I define associative algebra of q-difference operators. It is an associative algebra generated by d plus minus 1, x plus minus 1 with these relations. Then I consider such elements. This is all monomials which are normalized in certain way which is convenient for me, and I consider this algebra, this associative algebra, as a Lie algebra with just commutator is a commutator, you know, and I obtain this Lie algebra, and then I consider a central extension of this Lie algebra. So besides first term, which was here, I get a central extension term. The central extension is two-dimensional, so I've got two central elements, and that's it. That's
x and t are misprint, yes.
What is it? Oh, really? Okay, yes. Here.
Come back.
Yes, okay. Yeah.
Integer of half integer.
Now there's no half integers. Now there are only integers.
Because I feel that m and n are integer and r and s are half integers.
There is such a notation, but I lack of letters. Yes, misprint is.
So what about the sign change from the first formula to the second one?
The first formula is what?
No, this slide you have two formulas.
NR, and then you have NR minus SN.
What's it? I changed the sign. Oh my God.
So this is a replacement e to minus e.
Q to 1.
What?
How it happens, nobody knows.
Sorry.
The next slide will have again this coming.
Yes.
And nobody can tell.
I really sorry.
The letters have a difference.
I copied the formula from. Yes, but yes, this is the formula I copied from my paper. So I think it is a good formula. We should check where I copied the formula on the last slide. Is it on as well as the paper? Okay, so this is the definition, formal definition, that it is a Lie algebra with basis ek KL. So for some reason I exclude 0, 0 because it would be in the center and nobody care about E0, 0 and two central elements and this is the commutator. Okay, so it's my algebra. Also I need to define so I've got a basis in this Lie algebra, but I need generators. So these elements generate the algebra as Lie algebra, but they are not. They are part of basis. This E, F, and H, and they are. Let me draw the picture. Сейчас какой-то вопрос.
Секундочку, просто хотела вам отдать. Валентин Сергеевич.
Ой, ну,
Я просто за вами бегаю уже, бог знает.
я не Валентин. Я уже взял бумажку, я не Валентин. Я Гонин. Okay, so I like to write the generators as of this algebra. I hope that people can see the picture. But maybe you don't. So, do you see the picture? Should I? No. What should I do? Okay. I see. Okay. So I think about these generators EKL as points on the plane. So EKL is a point with coordinates K and L. Okay, and I want to my generators E is just the first column. So here is E0, E1, E2, etc. No, as you can see, E1K here. The 0 column, I call it H, and there are HK generators, and -1 column is F. That's the picture. So, and there are these generators. No, and it is an exercise that these 3 columns generate the whole algebra. Okay? Okay. Okay, now I'm going to define a Fock representation of the algebra. So the algebra will act on a Fock space, so let me introduce notation. First of all, let us consider Heisenberg algebra with such a relation generated by AK. Then I consider Fock module generated by cyclic vector such that A0 acts by multiplication on alpha and AK annihilates this alpha vector for k greater than 0. That's like my setting, so I consider such Fock modules. Also, I want to introduce some notation. It's a bit not formal. So I consider operator Q. This operator like shift. It's commute non-trivial with A0. So the point is that I will never have operator Q itself, but I will have operator E powered by Q, and it will act from Fock module to Fock module with shifted alpha. Okay, So like I defined phi of z here, but I promise you that I will only use exponents of phi of z. And here's the formula for a representation of my diff-q algebra, which is called Fock representation.
It's like fermionic representation, but instead of just two fermions, you have this.
Yes, yeah. I will have such a slide. You are like looking forward. It will be two slides below. Okay, so in particular, this operator shifts alpha by -1. This operator shifts alpha by +1, and totally we land to the same Fock f alpha. So these operators are indeed operators from the Fock space to itself. Okay. Let me comment that this H, if you consider such central charge, then Hn satisfy relations of Heisenberg algebra. So this Fock is irreducible representation already for Hn. And it turns out that the whole algebra also can act on this space. Okay, here I have rewritten this. So these are formulas from the previous slide. And here I have rewritten this formula a bit. So here I had two exponents which are not normally ordered. And then I just normally ordered them. So when I normally order it, first of all, when you consider normal ordering of two exponents, you've got this 1 over z minus w. And it's here, it's 1 minus q. Also, one has to be careful with zero mode, and I obtain parameter u here, which equals to q in power minus alpha. So it's an exercise to check that this formula after normal ordering will give this formula, these formulas, and now it is evident that we act on a single Fock space. I will, about my notation, f alpha is just Fock space for Heisenberg algebra, and I write fu for Fock representation of whole diff-q algebra. Okay, that's my module.
Что вы имеете в виду?
Ну, в смысле, ну я, окей. Fu.
Альфа это оно, да?
Alpha, yes, is okay. I define this space Fa alpha as representation of Heisenberg algebra, and then I constructed a structure of a representation of whole diff-q algebra, and I denote this representation. I don't know how to write Gothic letters. So I denote this representation as Fu. This is the obtained representation. Okay. So, okay. As Andrei Vladimirovich was expecting, I need also fermionic construction, so I consider Clifford algebra, which is generated by psi I and psi j star. So these are relations of Clifford algebra.
Half integers.
IJ,
No,
an integer.
Yes, they are integers.
So you have 0 mod, psi mod, psi mod?
Yes.
Yes.
But yes, yes. Okay, so okay, here are relations of Clifford algebra. So psi anti-commute. Okay, you can. There are different notations. You can think that these are half integers, these are half integers, and put minus half here and minus half here. Or you can put minus 1 here and nothing here.
So it's probably senseless, but it's kind of 0-1 system, yeah? So as you write down, psi start as spin 0 and psi as spin 1.
Yes, and maybe it's a bad choice because I suffer a lot about with these q1/2 factors which appear everywhere. So if I would write the paper again, maybe I would put another notation, but nevertheless. And then I consider module fc of this Clifford algebra, and this module has a cyclic vector L such that psi I annihilates this vector for I greater or equal than L, and psi j for j strictly greater than minus L. This module does not depend on value of L, since you can find L plus 1 cyclic vector with analogous cyclic vector for L plus 1 by this formula, or L minus 1 by this formula. So this is the fermionic space. Okay, and
I didn't get lost. What is lost? So L is what is it?
Okay.
Vacuum with charge L, yeah?
Yes.
And so
yes, and I said that
psi minus L shifts it to
yes. Nothing is said. Okay, and I claim that formulas below determine action of div q on f psi. Here are the formulas, and there's a standard thing which is called boson-fermion correspondence, that you can substitute instead of such exponent just psi, just this fermion. So these formulas are more or less coincide with these formulas. Okay, and maybe I should write on the slide that this representation which I have obtained here, it's not irreducible, it's direct sum of, so remember you've got this L on the last slide, and this L, this vector L is actually the highest weight for this representation is direct sum of Fock representation with shifted U, sum over all integer numbers, so this vector L, which was defined on the last slide, is the highest weight vector in corresponding fq powered by Lu. Okay. Okay. So all this is like a standard facts, just standard facts about this Lie algebra div q. And now my talk actually starts. I consider some sublattice construction. So consider full rank sublattice lambda in Z2 of index n. What means index? No, you may define index in different ways. For example, index is like number of elements in quotient, or you may choose a basis of this lattice and then compute the determinant, and determinant will be n. These are equivalent definitions. Okay, and we consider vector subspace with basis EAB, where A and B are where vector AB is in our sublattice. Okay, so and also we take our favorite central elements, and I claim that this subspace is closed with respect to commutator, and it's quite evident because when you take commutator of two vectors, then you just obtain the element which is sum of two vectors with some coefficient dependent on q. So this is indeed a subalgebra. We denote this subalgebra by div q with superscript lambda. Okay, and I claim that this subalgebra is isomorphic to div q to the n, depending on a choice of basis in sublattice. So I have to choose a basis in sublattice v1, v2, and A10 is mapped to the first element of this basis, AE01 maps to the second element, and so this is my map. So here I've got vectors. Okay? Okay. So, and our goals for next several slides is to give explicit bosonic and fermionic constructions of restriction of Fock module to this subalgebra. So I have a subalgebra which and I'm going to restrict my Fock module, and then first of all I want such formulas which I had on the previous slides, like bosonic formula, fermionic formula. I call this explicit constructions, realizations, and the second thing which I want is to study this representation as an abstract representation. I want to understand, is it irreducible? If it is reducible, then what are the direct summands, and so on. So this is my goals. Okay, yes, maybe there's some questions.
Что сказано, что вот можно взять такую подрешетку, как индекс n,
да,
и это будет подалгебра.
Да.
Значит, любую, да? То есть любые эти квадратики. И теперь вы хотите для них написать фермионное представление.
Это первый вопрос, там, фермионное.
Отличается из предыдущего, в чем расширение какого-нибудь?
Ну, в общем, the first question actually is designed to be solved immediately. So these questions are actually like easier, but then we obtain.
We don't understand what is abstract representation.
Whether it's reducible or not. Fock model wasn't reducible. When we restrict to subalgebra, it can mean that we obtain some sort of new representation. And if you want, at the end of the day, this twisted representation of the Virasoro algebra, which was on the first slide, was obtained by some sort of this construction.
And the representation from the first slide is reducible.
Да, ну и вы знаете, что последнее Вирасоро, которое там, оно превратится.
Я догадываюсь.
Yes.
А вопрос...
Ну, который там, здесь же вообще пока не включен, который там. Нет, это тонкое, это самое. Но вот, сейчас не понял, но вот здесь был FU, который, он приводимый, да?
FU, нет.
FC приводимый.
FC.
Очень просто приводимый.
Ну, в общем, просто приводимый по сумма, прямая сумма этих квадратных модулей. Вот, с разными зарядами, да? А значит, все-таки еще раз скажите, что вы хотите, значит, для подрешеточки какие-то найти сейчас представление свободных полей, а вот это пункт номер 2, это что такое?
Там окажется больше, чем одно свободное поле, если добегать наперед. Там может оказаться больше, чем одно свободное поле. То есть FU это просто Фоковские от одного Гейзенберга, а вот такая вот для подрешетки их сразу может сказаться много. Not I also should comment that, I maybe will say it. So this polynomial construction depends on the notion of Chevalier generator. So.
Yes, I will say it on the next slide.
Нет, но это же так, собственно, бывает, что если, я так понимаю, что вот если взять какой-нибудь обычный, да, бозон, и сказать, что там вот его сделать каким-нибудь периодичным, да, и в нем, соответственно, может быть и обычный периодичный, и непериодичный. Тем самым это как бы уже будет, ну, типа повышение ранга, да?
Да,
и вы говорите, что немножко это под решеточкой, это тоже повышение ранга.
Да.
Okay, so this is an example of sublattice, and like I had two questions on the previous slide, and also I said that the representation depend on the isomorphism depend on bases, and I can choose different bases in this sublattice, and I will consider two bases. How to pronounce? Bases. Okay, bases like blue bases and red bases. So what are so I've got axis x and y, and my red basis is the first vector is on x axis, and the second on the first row. Here the first vector on the first column, and the second vector is in 0 column. No, the sublattice is the same.
Sublattice is given by big circles.
But we have two different bases in yes, bases. Okay. Yes. Okay, and let me start to answer. So I wrote here that I'm going to answer the first question for blue bases, and it's actually very easy. So let me, I don't know. Okay, let me write this. So I claim, for example, I'm going to write formula for E of z, and for new E of z. So like, don't like this picture, it's actually messy. Let me erase it and draw again. So here's my 0 column. Here is first column. And in the maybe let me write. Okay, and in the first column I have to choose some, like, I know how these elements act in FU. This is just my E of Z. And I just choose some of these. No, this is sum En Z minus N. And I just choose some of them. On the picture I have chosen like 1, 2, we have chosen this, 1, 2, 3.
Number 2, number minus 1, number
yes.
minus 4.
Yes. Okay, I have chosen some. So
you know formula for the whole column, and you want to find formula for the sub.
Yes.
Some part of the column.
Yes, yes. And okay, let me denote these initial elements of initial algebra by E. Okay, maybe I want to a bit change my notation. I want the big subalgebra be div q powered by -1, and then consider embedding of div q. This is actually convenient. And generators here leave elements E 1 over n, and here leave elements ek. Okay, that's my notation. Hope everybody can see it. Okay, or guess what I'm writing. Yes, and so the formula is following. So okay, let me write the formula, and then okay, so let me assume that the length of W2 vector is n. Okay, no, on the picture I have n equals 3. So, yes, it is my W2 vector, and it is n0. And my W1 vector, thank you, 0, n. And my W1 vector is 1 and twisted. And then I need these generators, and this is exactly what I write here. So I have to take k, which have the same residue and which have residue and twisted modulo n. And that's the formula. That's how I find my E of Z for new generators. Maybe it is the crucial point about all these constructions, so please ask questions. If you don't see the formula, I can remove the screen or something like this. So
probably you also should write down formula for another generator.
No, it's more or less straightforward. So Hn, new Hn is old Hn, which no, k multiplied by n, and f of z Actually, it's quite analogous.
You could also write it as a sum of the units of order n.
Ну, это сейчас произойдет, а сейчас произойдет.
Yeah.
В известном виде сумма пропускается единицы.
Yeah. Yes. Okay.
Looking for the pointer.
Yes. So these are formulas that I just took these fat points and wrote the generating function. So hope everybody can see it and understand. Other questions?
Мне было непонятно, что это значит формула.
It's a statement. It's a statement that I can express new generators via old generators. And if you want to
Just a subset of the old set of old ones. What else?
yes. But I want a closed formula, like, no, okay, your question is actually like motivating me to switch to the next slide. And
I don't understand, this is not even a subset. It seems for me that this is just the same current.
No.
If you put, I can put that k is equal to ntw plus n times p. P is some new summation variable. Yes? I can perform this summation explicitly, and I will get n times p, where p is new integral number. Yes? K is equal to twisted is equal to n twisted plus n times some p, where p is new integral number.
Yes.
And then I put it to z. Yes.
Yes.
And get like summation over integral number.
The summation of the integer number. Yes. Actually, there's summation of the integer, but only some subset of these old generators appears. So
yes.
if you have Bostonization for all generators, then from this Bostonization we can somehow construct Bostonization of the
Вы
problem.
сказали одно Мишина, что здесь часть старых генераторов с Q равным, ну, в общем, единичкам на маленькой степени от предыдущего уровня, да? Это первая часть. А вторая, что из них вот застряпали такие производящие функции, и пока непонятно для чего.
Не, ну как бы это есть наши токи, которые мы хотим выражать. Мы раньше писали
да.
Мы выражали такие токи.
Естественно, а теперь нарисовать их нельзя, это вот, как-нибудь вот на это решить.
Ну это вот первая колонка, вот там где W1, вот тот, что снизу, и тот, что еще снизу. Вот они.
Сейчас вдоль W1 кто это? Вот эти.
Нет, вдоль этой колонки. Ну, то есть надо выделить эту линию каким-то цветом, сказать, что
то есть они просто вдоль идут тоже по вертикали, да?
Ну, потом они идут как параллель, то есть линия параллельна W2, то есть в этом месте. То есть то, что W1 лежит в первой колонке, то есть то мы его имеем шанс выразить, а W2 вертикально, что вот прям вообще. В общем, прямо реально используется вот такой синий выбор-прайс.
Okay, so if this is clear, if the formulas there is clear, then we are ready to apply the formulas. But first, let me state the answer. So I introduce n copies of this Clifford algebra or n fermions. I call these fermions psi, and this A is from 0 to n minus 1. E of z is, I will not write other formulas because the formula for f is analogous, formula for h actually also clear. Okay. Okay, and this is the answer for E of z, and it is expressed via n fermions. And how did I obtain this? Here's the proof. So this psi and cb star are are defined by these equations. So you indeed just consider modes of all psi and divide it in different. Psi I is modes of psi I are modes of old psi with fixed modular n. Yes, exactly. Yes, and the same for psi b star.
As you predicted.
Yes.
Composed.
Yes, I have one fermion and then I divide it to n fermions. One Clifford algebra is infinite dimensional, hence it's n times the power of Clifford algebra. Yes, and I've got old formula, and then I just substitute this formula here, and then I want to find modes with fixed with k have the same residue modulo n, and it's an elementary exercise after substitution.
Если просто посредством получается все возможно, а и b, вот если мы хотим оставить только моды, сравнимые с n-твиста, вот остаются только а минус b равно b минус a равно twist.
Сейчас, в смысле, вы хотите сказать, что есть какой-то смысл при произвольных алгебрах?
Вот если он просто подставляет вот эти формулы, у него будет сумма по всем а и b. Он берет, пси подставляет, сумма по всем. Ну, это знаешь,
куда подставляет? Вот
формула 27, формула 28.
Да.
Получается сумма по всем возможным а и b. Без какого-то условия.
Да.
А в формуле 26 есть условия. Условия происходит из того, что формулы
что как бы вот внизу это объединение всех этих.
По всем
28 это
28, сумма всех 26 по всем умножена на 200. Да?
Okay. Yes, and I think everybody seems to sleep, but I think it's a shame. Коля, is it clear? Yeah.
The first coordinate of W1. The first coordinate of W1. Why is 1?
First column is W.
First coordinate to W1 is 1. You assume that there exists of such basis.
Did I make mistake?
Yeah, no, you didn't make any mistake.
Yes.
But this, I mean,
why?
If you have any point in the first column, then we have such basis. If you do not, then we need to somehow
Okay.
rescale our.
Yes. Let me answer the question. So I consider it a bit specific lattices, but actually, if you consider lattice with like you take some rows, some columns, whole columns, all points in columns, and nothing in between, then and you restrict your Fock module, then you obtain just Fock module. So it's trivial. You may assume at the beginning that this number is 1. Thank you for the question.
Просто вы можете выкинуть.
Да, можно просто. Ничего нового не получим, ничего интересного. Okay. And here is so we used fermionic formula and we obtained fermionic formula. We can obtain bosonic formula for E of z using bosonization of these n fermions. And you will obtain a formula in terms of n bosons. But also there's another formula, another bosonic formula in terms of one boson. And it's here. So here I used, no, and it's what you would call boson with non-trivial monodromy, I guess, after some rewriting it. Okay, so psi is primitive root of unity of degree n, and no, my basis is the same as it was, and E of z is expressed as follows, and this is just that this formula can be rewritten as sum over roots of unity, as Roma predicted. And then I just substitute these two ordinary bosonic formula and get this formula.
And this should resemble formula from the first slide, formula for...
Yes, secretly it resembles formula for the first slide if you prime unity, if your n is 2. So if zeta is just -1, then you have sum of two summons, and this will be the formula. I will have a slide about this later. Okay, it's okay.
We have boson which consists of, which is the sum of bosons with different boundary conditions, with different monotomies.
Yes.
And fermions, we can use them, we can bosonize in terms of n ordinary bosons, or we can write formula using n bosons with different monotomies.
Yes, and here is the formula which I was surprised on the first slide. Here I have like non-integer powers, and I perform some summation and then obtain only integer powers. Okay. So this is what you asked me, what is study as an abstract representation, and I will give you the answer that my module generally is not irreducible, and it is, if you restrict to V, to sublattice and identify diff Q using V basis, then you obtain, then the restriction is sum of products of Fock modules. That's the statement. So the representation is not reducible, it's direct sum of, actually these representations are irreducible, and these are well-known representations.
And summation goes over...
Yes, and summation goes over, no, so the numbers like L0, L alpha, LD, so this is a tuple of D numbers, and sum of all these numbers equals 0.
And we also have some sort of...
Integer.
Yes, all else are integer.
Yes. It's, we write Q because it is root lattice for SLD. Okay, and he's...
We also have shift of U in the formula. U Q in power alpha over n.
Yeah. Here I have some shifts. Actually, these shifts ensure that my module is irreducible, because module is reducible is if fraction one parameter over another parameter is power of Q, and these fractions are never integer power of q. It's a certain rational power of q, as you can easily see.
Rho over 2d, something like this. Ну, они так,
Ну, каждый, да, каждый.
Ну, это как бы что, импульс сдвинуть на ρ, поделить на какое-то число. Как у вас это?
Okay, here's an example. So what is d? So there's an important number d, which is here are d multiples, and summation is over qd. What is this number d? Number d is here. So as we discussed, it makes no sense to consider such sublattices that we have nothing between two columns, but it makes sense to consider sublattices that we have nothing between two rows. So, and
some gaps in rows.
yes, assume that we like we consider some sublattice, and we of course we like choose something in 0 row, and then we take nothing in the first row, nothing in the second row, and then we go to row number d. So this is 0, this is d, and then we this is my number d. Yes, and let us consider example d equals 1. If d equals 1, then I have a point in the very first row. And my v-basis, recall that v-basis is designed as follows, that v1 in the 0 row and v2 in the first row. No, if there is something in the first row. Okay, and so we've got a Heisenberg subalgebra which can correspond to v2 ray. As I told you, the relations ensure that this is a Heisenberg subalgebra. So it's a sketch of a proof. In this case, I will not go into details. So we've got this subalgebra, and we can look on the character of this module and see that this module, after restriction, is still Heisenberg, is still just one fork for this Heisenberg subalgebra. If you've got points on each row. Okay?
Central charge over each amount.
Central charge before restriction was c equals 1, c prime equals 0. After restriction, we still have c equals 1 if d equals 1. C equals g generally. And c prime is still 0 because this is commutative subalgebra. So I'm saying you that the restriction is Fok. Fok have these central parameters, and I'm not lying. You restrict, and you still have these central parameters.
And for generic, the central charge will be d.
Yes.
Yes. Sublate construction, you obtain interpretation with non-trivial central charge, but very special ones.
Ну.
За счет чего? Нет, там какая-то формула, они как-то преобразуются, что ли, через штучку?
Ну.
Центральный заряд не должен ничего.
Мы сделали под решетку. Мы взяли какую-то. То есть на самом деле на этом представлении, которое есть такая сумма, есть большая симметрия. Вот если мы забыли какую-то большую симметрию, то вот для этой алгебры это представление уровня D.
Тензорный центральный заряд?
Ну, потому что под решеткой.
Нет, это как все из истории, что вот n бозонов и кого-то складываете в один.
Да.
Дальше как посмотреть, там или n центральный заряд, или один. Но я не понимаю, где вот эти молодые люди.
Где что?
Где они жульничают?
Вот.
Как вот из формулы следует, что один центральный заряд переходит к другому?
Ну, потому что, когда вы берете центральный заряд, это что такое? У вас есть Гейзенберг направленный вдоль какой-то оси, вы смотрите какое-нибудь коммутационное соотношение с собой. Значит, ну, коммутационное соотношение с собой, значит, у Гейзенберга есть направляющий вектор, вы должны разделить по базису.
А вы просто перенумеровали, да? Вот сказали, что dn, там стали n, да? И dn.
Вы так никогда не делали?
Нет, можно.
Okay.
Окей.
Okay, so once again, that my argument is that when I restrict to this Heisenberg, it is just a Fock module for this Heisenberg, and actually, if your representation is Fock module for Heisenberg, then you have no other opportunities besides this representation is fu for some u. Then you have to just calculate u, and it's an exercise. Okay, so this was my first example, and second example maybe more clear, I hope. It's for another sublattice. So I take v1 equals 1, 0, and v2 equals 0, n. So I take all point in first row and all point in row number. No, here n equals d. I write n because I like. Maybe I do. Yes. And then, in this case, you remember that I've got these two bases, V1 and V and W bases, red and blue. And in this case, these bases coincide. So, and for W, no, this is just this basis. It's clear. And for W basis, I had fermionic formula. This is the formula for. So this is my restriction. And when I look at this formula, I see that here are summands with exact that here are formulas for just ordinary fermionic formulas. So each summand determines representation like Fock fermionic representation, and it is decomposed to such f. And but we've got n summands, and hence we have tensor product of representations. Different fermions can have different charge, this L which I had before, but if we started from Fock module, then total charge must be 0, and that's the sum. Okay? Clear?
Чего вы говорите, я не понимаю.
Сейчас, нет, кажется, я очень понятную вещь сказал. Сейчас, давайте по-русски.
Берете специальную решетку и чего?
Вот, пишу фермионную формулу. Написал. Вот каждое слагаемое задает мне... Это просто фермионная формула, вот, которая соответствует одному фоку. Вот. Ну, значит, если мы ну, как я говорил сначала, фермионная формула — это вообще приводимое представление. Там будет вот такая сумма по L-альфа, да? Вот. А если у меня еще n слагаемых, то у меня будет тензорное произведение, правильно? Вот. И у меня получается сумма тензорных произведений. Вот. Но если я стартовал не с фермионного представления, а с фоковского, то у меня есть условие, что суммарный заряд равен нулю. Вот, и вот оно.
Ну, еще раз, чего в чем утверждение? Значит, это вот, чего неверно, что для произвольной решетки, а что для этой, например?
Ну, my point was that there's a decomposition and similar proof even for general sublattice. But for simple sublattice, it's easy to write the formula, and it's easy. No, so I think that I have proven the theorem in particular case. And case in and proof in the general case is analogous, but a bit more technical. That was my point. Okay.
So this sublattice comes from the fermionic charges with respect to n fermions.
Mm-hmm.
This is
okay. Clear.
Maybe it's time to go to W-algebra.
Okay, okay, maybe at least it's time to. Okay, actually, I also put a slide, which I was forbidden to put it, but still I put it. So there's a nice corollary from this decomposition. It's an identity for conformal blocks. You have some sort of vectors which are called Whittaker vectors. Yeah.
But for conformal blocks, this is something like, you know, in your paper you have algebraic solution for two. This proof was fabric injection in your paper.
So there are some famous Whittaker vectors in these modules, and if you consider pairing of Whittaker vector with itself in this module, then it's something explicit, some double Gamma symbol, and by definition, this pairing with itself in these complicated modules is Nekrasov partition function, and these summands are orthogonal, and hence we get this identity.
Is it forbidden question what is the Whittaker vector?
What?
Is it forbidden question what is the Whittaker vector?
You have forbidden me to talk about Whittaker vectors, and gave an order to talk about W-algebras. So I reject your question. So we are moving to W-algebras, but slowly. So also there's SL2Z action on my algebra, and it's quite analogous to what we actually before we had some more general situation. We had embedding of algebras, and for SL2Z it's an algebra automorphism, you can, if you've got any module M, then you can define twisted module M sigma. M sigma is the same vector space, but with different action. New action of element let X be an element of my algebra. The new action is not V, is expressed via old action. That V goes to my automorphism applied to X, and then sigma of X is an element of my algebra, and then I act on V using my old action, and that's my new action. I wrote here for the same for rho, where rho is homomorphism from algebra to operators on a vector space. Okay, is it clear what twisted module is? Okay. In particular, if we take Fok module and for this matrix, we obtain twisted Fok module, and these are values of central charges. Cn, C prime, and prime. It's a low row of the matrix.
Maybe it's unclear. And does the sigma act on the vector space or?
No. If sigma would act on a vector space, then we would obtain isomorphic representation. For some sigmas, we do if n prime equals 0 and n equals 1, we've got this upper triangular matrix, and we will obtain isomorphic representation and can descend action of sigma to the vector space. But generally there's no action of sigma on the vector space, and hence we obtain non-isomorphic representation.
This is given on the level of central charges.
Yes.
So you can write equal to zeros and then equal to 1.
Yeah. Okay. And why did I talk about this abstract stuff? So let sigma be transition matrix from V basis to W basis. And now I want to restrict to use isomorphism using W basis. And W basis is still drawn here. And then I will obtain, it's a direct corollary from the previous theorem, that I will obtain, before we had direct sum of Fok modules, and now I have direct sum of twisted Fok modules. Okay? Okay, and that's the theorem. And now let us try to and now I'm going. So the slide is called twisted Fok modules, and let us change the perspective. And now I'm going to study twisted Fok modules. Actually, it is one of the questions which Misha asked me. Yes, and so suppose I'm interested. I'm starting from some sigma, and I want to solve inverse problem. I want to find sublattice lambda sigma such that I will obtain sigma here for restriction. When I restrict to W basis of this sublattice. And there is such sublattice, it's an elementary construction. You take this, and indeed, as I said, sigma is transition matrix from here to here, and if I apply sigma to this basis, then I obtain W basis as what was promised.
What is F sigma?
F sigma is twisted Fok module. So I take okay, it was
acting of Fok generators or Geisenberg generators with non-integer with twisted indices.
No.
What is it?
Okay.
No, this is just something abstract, yeah?
Okay, let me say it again, but in... Что так, что... Может, эту картинку не надо было стирать? Твистованный Фок, он как бы такое представление, что он... Вот у меня есть, что как бы он, это то же самое, что обычный Фок, как векторное пространство. То есть вектора в нем тоже те же самые. Вот. И вот я хочу...
По-другому действует кто-то. Да?
Алгебра по-другому действует. Что я хочу подействовать элементом... ну давайте я вот так...
А и окрест. Можно писать а и окрест сигмы или нет? Или это какой-то бессмысленный вопрос? Или в нем действует твистованная алгебра, это вот это, ваша уже из этих ешек.
Ну...
Вектора те же самые, это означает, что а и окрест те же самые.
Ну, там есть те же самые а и окрест, но они нам, ну, может быть, мы их просто уже не настолько любим. Ну, в смысле, они для нашего...
Любить вы можете кого угодно, да? Пока новой конституции. То есть по-другому действует буква Е.
Да.
А как бы...
Аж по-другому действует. Генератор Шевале действует по-другому.
Шевале это Е или Аш?
Это Е, Аш и F, как полагается.
Ну Аш раньше были просто
Гейзенберг.
Сами Гейзенберги.
А сейчас это может стать, например, четный Гейзенберг.
Ну понятно.
А может стать кратный 3. То есть они могут как бы повернуть. И от этого у вас подскочит уровень.
Угу.
И тем самым можно получить некое нетривиальное расстояние уровня 2.
Понятно.
Просто да.
Сейчас, а Гейзенберг переходит, тут написано какое-то производное.
Гейзенберг какой почему? Написано алгебра. То есть Гейзенберг, который был направлен то ли с Y, скажем, перейдет Гейзенберг, который направлен то ли какой-то другой ось. Из-за этого не подскочит уровень.
Сейчас, а это можно понять на какой-то картинке? Типа у меня было два вектора 1, 0 и 0, 1, и он перешел в какой-то вот такой хитрый, и вдоль него Гейзенберг уже какой-то не с центральным рядом 1, а непонятно.
Ну все подсказано.
Да. Угу.
Чего я
Нет, на самом деле есть обычный Гейзенберг, который на 1, 0 и 0, 1. Эти уже...
Ну да.
Угу. Да.
Хорошо. Ладно.
Окей.
Извините.
Okay, and so now I'm going to study this twisted Fock modules, and here I constructed some lambda sigma. It's a particular sublattice which is expressed via coefficients of this matrix sigma, and I want that this twisted Fock module to be restriction of Fock module for and here I used W basis. So, no, this is restriction which we were talking half an hour or even more. And I claim that for every sigma, for any such matrix, I can, no, if I take this W1 and W2, then I obtain a twisted Fock module. Okay, and so what do we see from this result? We see that twisted Fock module does not depend on the first row, does not depend on m prime and m, since they are not here. This result actually gives us fermionic construction and bosonic construction of Fu sigma, since we have constructed bosonic and fermionic construction of this module. Okay? And also, like, I want to say that div Q is specialization of Ding-Kiochro algebra, toroidal Gilvan algebra, and there's a question what can sublattice business does not make any sense in case Q not equals T, but this twisted Fock modules make sense. SL2Z still acts. However, you cannot embed a subalgebra for generic sublattice. And there's a question what can we say about this twisted Fock module? And it's an interesting question. Probably we have deformation of fermionic construction and nothing more. Of bosonic, of fermionic, yeah. Okay, but let me move forward. Maybe there are some questions because we will move to W-algebras.
Maybe there are, but it's already.
Okay, it's not time for me. There's no time.
Formulate something at least here.
Okay, so let me give horrible definition of W-algebra. First of all, we define some function, then the relation of W-algebra. So the algebra is generated by take Km. Here K is between 1 and n minus 1, and M is any integer number. It's convenient to add T0 and Tn, which are just 1. So when I write TKW, it means generating function of these guys, and there are two relations. When first relation is about interchanging T1 with Tk, and when you interchange them, you have to write this function, and the answer is a delta function, some delta function terms and derivative of delta function, and the coefficient is expressed via tk plus 1. And yeah.
Derivative with respect to W?
No, here I meant that you got a function, you can in one variable, then you take derivative and then substitute W over Z. And here's another relation, it's analogous, but instead 1 you've got n minus 1, and we go from k to k minus 1. That's the relation. These are some interesting algebras. Limit q to 0 give W-algebra from CFT. W-algebra with some special central charge, like n minus 1. For n equals 2, we obtain Vирасоро algebra with central charge 1. As was on the first slide. Okay. Let me talk on connection of this W-algebra and diff Q algebra. So let me define some phi plus and phi minus, some generating function of Geisenberg, Ij, and multiply. So let me, maybe everybody are tired, but let me try to stress a point. Before we considered columns, and you can consider first column, second column, third column, etc. And we obtain some currents which are of generators of the algebra. And here I consider some other currents. You can either take just column number k, or you can take first column and consider kth power. And what you need to do to study W-algebra is to consider kth power. Okay? Then you multiply by some factors, and now this tk, and we has defined some elements in my algebra. No, in some completion. Yes?
How to take this case power? There were some fields in the same point.
Yes, but due to relations, E of Z and E of W can have pole only in points they have resonance only for z equals q to the plus minus 1 w. So and this is in relations of the algebra. So it is completely safe to like take product of two fields and put them in the same point. Yes. So these are my tk tilde, and as I said on the previous slide, tn equals 1. If I say that tn tilde equals 1 up to some constant, then no, let g mu be ideal generated by this relation. Okay, quotient of diff q over this ideal, if I say that this is true, is my W-algebra for SLN, which was defined on the previous slide, tensor Heisenberg algebra. So I make my t tilde commute with my Heisenberg. That's why I put exponents here. And now my whole algebra is tensor product of Heisenberg and this W-algebra, which is generated by this t tilde. That's the statement. Okay, so I said an abstract statement that W-algebra is subset in the quotient, but I copied it here. But also this ideal indeed acts by zero on tensor product of Fock modules. Here mu is some constant, and hence my W-algebra actually acts on product of Fock modules. Okay, and here, so let me go back to the very first slide and explain what we did. We have this representation of W-algebra, but direct sum of tensor product of Fock modules also is a representation of W-algebra. No, this W-algebra for n equals 2 is called Virasoро. So this is a representation of Virasoро. Hence, this is a representation of Virasoро. We've got this twisted, we've got this formula for E of z in terms of one boson with non-trivial monodromy, and hence we obtain a formula for Virasoро.
So you multiply by this phi plus and phi minus.
Yeah, exactly. We just do this and
then
yes.
So even modes disappears and only odd modes.
Yes, we want this. We multiply by exponents to make this current commute with Heisenberg. Heisenberg now are even modes of AK. And we kill all even modes of AK, and there are only odd modes. Actually, here was a joke that we killed all odd modes, since we can call it odd bosonization, and generally we call this type of bosonization strange, and we say that odd bosonization is a particular case of strange bosonization. Okay. So that's how my machinery produced the formula. Other questions? Everybody is sleeping? Okay, that's a terrible slide which, with relations of diff q algebra. I want to say that the proof that quotient is W-algebra actually just straightforward check of relations, and we've got relations in terms of Chevalier generators for diff Q algebra, we've got relations for W-algebra, and we just check that this is the same. Okay, let me talk a bit about this twisted W-algebra. So before we have the relation. Yeah. But it's not the last slide, but I will be, okay. Yes, we can skip. Yes. So this is the same relation as before, but before I have a relation in mods. In current forms, I've got currents here, and now I've got mods. So I just like copied the relation for W-algebra rewritten in the current, rewritten in the mods form. But now I say that this TKR, R is not integer anymore. It's a rational number plus integers.
So what change in commutation relation? Where is n to W?
So the summation.
So just as a range R.
It's a range of R and S.
Yes. So the commutation relations, the formula for commutation relations, looks the same if you write it in mod form, but now this TKR, R is already a rational number. And you can see that if k equals 0 or n, then these are integers. And it makes sense to consider also such currents T0.
Boundary conditions remain the same.
Yes.
In between we have some shifts of the monod.
Yes. And this is indeed a different algebra. Yes, but it's still somehow no. It's quite analogous. There's a quite analogous connection of this W algebra and.
This happens only after q-deformation. For ordinary W algebras, there's no way to have such twisting.
Yes.
There's no notion of twisted Virasoro, but there is a notion of twisted q-Virasoro.
For example, if you take our q-Virasoro and consider limit q to 1, then you get just odd Heisenberg. You do not obtain any interesting algebra, unfortunately. Yes, Anton. Okay, so this connection between W algebra and diff Q, at least on the level of theorems, looks very similar. So we've got this T tilde elements as before, and now we say that T is not a constant, but constant times Z to power n twisted. This is my ideal generated by these relations. Still, there's an algebra isomorphism, and also still, but now this twisted W algebra acts on tensor product of twisted Fock modules. So now we can assume, so we've got like this W algebra depends on two parameters, like SLN and n twisted. N twisted actually a residue over n. It does not make, no, you can add n to n twisted, it will be the same algebra, as you can see from the definition. Nothing changes. Okay, and now you can have greatest common divisor of n and n twisted. I call it D. And then the matrix sigma, that twist from SL to Z, is a matrix. So you divide n and n twisted by the greatest common divisor. And then you can put any m prime and m such that this is a matrix in SL2Z. And so that's my sigma, and my twisted W algebra acts on this space. Okay, and so when we said that it acts on this space, it automatically, no, since we constructed Bosonization of singular Fock module, twisted Fock module, we can obtain Bosonization of W-algebra.
Let me comment. If there is no sigma, then what is the standard state? The standard q-deform W-algebra appears as a tensor product of n Fock modules. But now we have a new representation of the level n. We can make ordinary Fock module and make twist. And obtain representation of the level non-trivial level. And here, actually, the twisted W-algebra acts.
Yes.
We can also make tensor product of twisted representation. And interesting question what happens if we take tensor product of twisted with Fock models with different twists.
Okay, and you can consider restriction to a sublattice. Then you obtain direct sum of twisted Fock modules, and here is, and on the whole direct sum there is an action of W-algebra. You can check that this relation still holds, hence there is an action of twisted W-algebra, and you can write explicit formula. No, you can make this odd Bosonization, or like maybe a strange Bosonization, better to say. Yes, and in case of twisted Virassoro, you will obtain some formula like this. Before you've got like sum of two exponents, and now you have difference of two exponents. And here you have to put z 1/2 to make all powers integer.
I equal to j.
Yes, sorry. So thank you for your attention. Are there any questions? Я тоже заметил. Поэтому я постарался. Yes, that's. No, if C prime is 0, then you obtain non-twisted W-algebra. If C prime is 0, that's a twist parameter. Like.
Other questions?
Questions, comments?
Question from Pasha.
So just about twisting W-algebra. So it seems that we can do some, I don't know, is the same twisting or not for non-q-deform W-algebra. We can say that some numerical expanded over halfway integer powers. Because the common relation between Virassoro and W-algebra and between W-algebra with itself, so we are allowed to do this. So is it related to your twisted W-algebra or not?
Миша, ты слушал вопрос?
I think it's not related. So, I mean, in this case, the twisting for W3 algebra will be something given by residues over 3. You said something about, I see, it was residues over 2.
Yes, so, and all this twisted W-algebra go to Hessian in the image.
Actually, we did not check it. We just checked for the Virasoro algebra. We were completely disappointed, and maybe one can study this.
I do not expect new algebras. No, I'm not sure. The result was a product of ordinary W-algebras in Heisenberg, for some instance.
Maybe.